Hello everyone, myself Sai Kumar. Now I am going to give a seminar in radar engineering and the topic is radar and its block diagram. First let me discuss about what is a radar. Here the radar is a detection system that uses radio waves to determine the range, angle or velocity of the object, and the applications of this radar is it can be used to determine or detect aircraft, ships, spacecraft, weather formations and terrain. So in this we can define radar as a detection system which uses radio waves to determine the range, angle, or velocity of that object. So, how the radar works? It's here. The principle of working is here. Next, there will be a transmitter and there will be a receiver and there will be a target. Here, there will be a transmitting antenna which will transmit a signal to the target. So, from the target, it will transmit a echo signal to the receiver, and here we determine the range to target. It is target detection, and here receiver is used to for target detection and ranging. Next, coming to radar block diagram. Here in this radar block diagram, as we discussed here, there are two sections of radar. One is transmitter section and another one is the receiver section. Coming to the block diagram, upper case shows the transmitter section and lower case shows the receiver section. In the transmitter section, we have duplexer, transmitter, and pulse modulator, and the transmitting antenna. And in the receiver section, we have low noise RF amplifier, mixer along with the local oscillator, IF amplifier, 2D detector, video amplifier, and display. Next, coming to the description about each case, transmitter section. In the transmitter section, we have the transmitter. Here, the transmitter is used to transmit a signal to the target. Next, transmitter. Here, the transmitter may be a power amplifier. Here, we have many types of power amplifiers such as klystron amplifier, traveling wave tube amplifier, or transistor amplifier. Here, the main aim of transmitter is to generate the electrical energy at the radio frequency. This is about the transmitter. Next, coming to the next one, pulse modulator. Here, the pulse modulator or the power amplifier. The power amplifier used in the transmitter produces a high power signal in the terms of megawatts. So pulse modulator can be used as a switch to on or off the power amplifier. This is the main advantage of the pulse modulator. Next, coming to the waveform generator. As the pulse modulator generates a high power signal, as the waveform generator generates low power signal by the waveform generator, which is and it is given as the input to the power amplifier. Next, coming to the duplexer. Here the duplexer can be used as transmitter or receiver based on time sharing basis. Now a duplexer is a gaseous device that produces a short circuit at the input to the receiver when the transmitter is operating, and it produces short circuit at the input to the transmitter when the receiver is operating, so that the high power flows only to the transmitter or the receiver. Next, coming to this is about transmitter section. In the receiver section, the first block used immediate to the duplexer is low noise RF amplifier. Here in this radars, the receiver is always used as a super heterodyne receiver. Low noise RF amplifier is used immediately to the after the antenna. This reduces the noise figure and produces RF pulse proportional to the transmitted signal. This is about low noise RF amplifier. Next, coming to mixer and local oscillator. The RF pulse proportional to the transmitted signal converts to the intermediate frequency, where it can be amplified by an IF amplifier. The IF frequency may be 30 Hz or 30 MHz or 60 MHz. Next block is IF amplifier. So the mixer and the local oscillator converts the RF signal into the intermediate frequency. Those intermediate frequencies are converted and amplifies the IF pulse. IF amplifier is designed so it can be used as a matched filter for the detectability of weak echo signals and attenuates unwanted signals. Next, coming to the second detector. Its purpose is to assist in extracting the echo signal modulation from the carrier. Next, second detector. The name secondary detector name comes from the in the circuit we have used a second diode, so it is used as a second detector, and the first detector is used along with the mixer. Next, coming to the video amplifier, it is designed to provide the sufficient amplification to raise the level of the input signal to magnitude where it can display. So video amplifier is used to raise the level of the input signal to magnitude. Next, here we didn't mention the threshold decision, but it will be in the receiver section. The output of the video amplifier, here there will be output of the video amplifier is given to the threshold detector, where it is decided whether the received signal is from a target or just from because of the noise. Next, coming to the display, here the display is the CRT. CRT stands for cathode ray tube. Next, here the displays are used as A-scope and PPI. A-scope provides range and echo power. PPI measures range and azimuthal angles. In addition, there are other displays like B-scope, D-scope, etc. This is about radar block diagram. Thank you.